So today we solve top 10 very important numericals on class 12 physics. Okay, chapter electric potential and capacitance. Chapter 2. So question number 1, the potential due to a point charge, calculating the electric potential at a point 0.5 meter away from the charge plus 5 microcoulomb is given. So that is given. So potential, that is V, that is equal to K Q over R. Okay. So here K given. Okay. K equal to 1 over 4 pi epsilon naught, that given. So that is equal to 9 into 10 to the power 9. So charge Q is a 5 microcoulomb, that is 5 micro means 10 to the power minus 6, and the distance is 0.5 meter. So 0.5. So point remove plus 10, 5 cancel. So that is, we get 9 into 10 to the power 10 into 10 to the power minus 6. So 9 into 10 to the power 10 minus 6. 4 volt. That's the first numerical. Okay. So SI unit of potential is volt. Now we jump to our second numerical. So potential at a center of square, the 4 charges is given plus Q, minus Q, plus Q, again minus Q, place the corner of a square of side A. Calculating potential, electric potential of the center of the square. So here the square, okay, and that is 4 charges plus Q, minus Q, again plus Q, again minus Q. So here the center potential here, calculating potential at point C. You have point C here. So the corner of square of side A, side is given, that is A, and the square the all side be the same. Now we see at minus Q charge the distance. The distance is very important. Okay, so that's the diagonal by 2. So we know the diagonal of square, that is A root 2. Okay, that's the diagonal of square of half. That's the diagonal of square, that is the half. Okay, that's the half, that is the half of the diagonal. So we get cancel, 2 means answer is root 1 by root 2, that is A by root 2. Okay, that's the A by root 2. Similarly, that distance also the same, A by root 2. That distance also be the same, A by root 2. That distance also be the same, A by root 2. So potential at here we see, that is V of plus Q. So suppose plus Q charge, so that is K constant plus Q over A by root 2. So actually they obey the superposition principle, you know that, so that's why just numerically added. Okay. Second is a minus Q over 4, sorry, actually 4 is not outside the common, so A by root 2, again plus Q by A by root 2 minus Q over A by root 2. Okay, so that potential VC due to plus Q, that here, VC due to minus Q, that's here, VC due to plus Q, that's here, VC due to minus Q, that's here. So plus minus cancel. So K times 0, that is equal to 0 volt. So potential at the center we get 0 volt. That's the answer. Okay. Now we jump numerical number 3. How much work is done is moving charge plus 2 microcoulomb between that 2 point having the potential difference is 50 volt. Okay. Work done. W by Q, that is equal to potential. So W equal to Q times B. So Q given 2 microcoulomb means 10 to the power minus 6 and get a V equal to 50 volt. So we get 50 to the 100 into 10 to the power minus 6 joules. Okay, that's a very easy numerical. Now question number 4. Potential energy of a system of charge, point charge here, plus 3 microcoulomb and minus 3 microcoulomb is placed at 2 centimeter apart. Calculate the potential energy of the system. Okay. So the basic formula actually the U that is equal to, okay, Q1 Q2 over 4 pi epsilon naught times R. So here 1 over 4 pi epsilon naught we know that is 9 into 10 to the power minus 9, and here the two charges 3 microcoulomb, 3 into 10 to the power minus 6, and there is a minus 3, so that the minus is outside that. So 3 into 10 to the power minus 6 obviously over R, 2 meter apart, so that is 2. So 3 3 is a 9, 9 9 is a 81 by 2. Okay, 10 to the not minus 9. Okay, that is 10 to the power 9. So into 10 to the power minus 3, let's get 40.5 into 10 to the power minus 3 joules. Okay. Question number 5. So capacitance of parallel plate capacitor. So parallel plate capacitor has a plate area 0.02 meter square and a separation of 1 millimeter. Find is the capacitance of the dielectric is air. So that's a direct question. C equal to epsilon naught A over D. So epsilon naught is given 8.85 into 10 to the power minus 12, and the area that is given 0.02 meter square by D, 1 millimeter. So milli means 1 into 10 to the power minus 3 meter. Okay, so 8.85 into 2, that is 10 to the power minus 12 by 10 to the power minus 3 into 10 square. So you cancel these two, you get only 10. So 8.85 into 2 minus 13. So we get 5 to the 10 carry 1, 8 to 16 plus 70 carry 1 plus 17 into minus 30 farad. Okay, that's the capacitance of the parallel plate capacitor. That's the given value. Number 6. If 10 microfarad capacitor charge is 100 volt, calculate the energy stored on it. So energy formula U that is equal to half CV square. That's a basic formula actually. Okay, that's a joule. Half C is given 10 microfarad 6 in 100 volt means 100 times 100. Okay, so that is get 5 into 10 to the power minus 6 into 10 to the power 4. So get 5 into 10 to the power minus 2 joules. Okay, that's a very easy numerical. Now question number 7. Combination of capacitor. There are 3 capacitor, 2 microfarad, 3 microfarad and 6 microfarad are connected in series, and the equivalent capacitance. Okay, find a total energy stored in 12-volt battery is connected. So easy. If connected in series, okay, if they are connected in series, so we know that the total capacitance, just series means, okay, that is series 1 by something. So 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by CT total, that is 1 by C1 means 2 microfarad into 10 to the power minus 6 plus 3 into 10 to the power minus 6, 1 by 6 into 10 to the power minus 6. If I 1 by 10 to the minus is common, so 1 by 2 plus 1 by 2 plus 3 plus 1 by 6. So 1 by 10 to the power minus 6. 2, 3, 6 is also 6. That is 3 plus 2 plus 1. That is 1 by 10 to the power minus 6 into 6 by 6. So 1. So we get 1 by CT, that is equal to 1 by 10 to the minus 6. So total capacitance is 10 to the power minus 6 farad. So that is 1 microfarad. That's the first answer. Second answer is to find the total energy stored in 12-volt battery is connected. So energy U equal to half CV square. So 1 C V is 12 square. So get 1 micro, obviously. Okay, that's a micro, 10 to the power minus 6. So 10 to the power minus 6, 144 joules. That is 72 into 10 to the power minus 6 joules. Get 76 microjoule. Very small energy store. Okay. This store is now next numerical. Effect of dielectric. A capacitor of a capacitance 4 microfarad has the air between the plate is connected to a 200 volt supply. Calculate energy stored if the air is replaced by the dielectric K. Okay, what is the new energy store? Okay, so now that energy U old, that is half CV square half C 4 microfarad 10 to the power minus 6 and V is given 200 square and get to 2 into 10 to the power minus 6 into 2 to the 4, 1, 2, 3, 4. 4 to the 8 and here 10 to the 4, so 10 to the power minus 2 joule. Okay, now air is replaced by the dielectric K. So here if K, so new capacitance C dash, that is K times old capacitance. So K given 5 here and the old capacitance is given 4 microfarad, 4 into 10 to the power minus 6 farad. So 20 microfarad here. So new energy U new, that is half CV square. CV is 20 microfarad 10 to the power minus 6 and the voltage is same 200 square. So that is a 10. So 10 into 10 to the power minus 6, that is 2 to the 4, 1, 2, 3, 4. So get simple 4 into 10 to the 5, 4 into 10 to the power minus 1 means 0.4 joule. Next, number 9. Question number 9 is calculate the potential of a spherical conductor 10 centimeter which has charge is 8.85 into 10 to the power minus 9 coulomb. Epsilon naught is given here. So potential V of a spherical conductor, that is 1 over 4 pi epsilon naught times Q over R, that is 9 into 10 to the power 9. Okay, you know that, and charge is 8.85 into 10 to the power minus 9. 10 centimeter means 10 by 100 times 100 here. So if I given data, so I think it's very easy to replace that. It is 4 pi into 8.85 into 10 to the power minus 12. If I replace by this term to that here, that is 8.85 into 10 to the power minus 9 into 10 square by 10. These term and these term are cancelled. So 1 by 4 pi. Okay. So 10 to the power minus 9 means 10 to the power minus 8 by or into 10 to the power 12. So 1 over 4 pi into 10 to the power 4 volt. If you want to calculate, please do that with calculator. Okay, just simple maths or calculation. Last numerical is two capacitors connected in parallel in 12 volt battery. After charging, they are disconnected and they connected to each other, and find the final voltage and energy loss. Positive plate are of one to the negative plate of other. That's a very important question. So two charge given, the battery also given. So first very easily to calculate the Q1 charge store. If connected in parallel, so obviously they are charged with a difference. So 6 into 10 to the power minus 6 equal to CV into 12. 12 6 are 72 microcoulomb, and here Q2, that is 3 into 10 to the power minus 6 into 12 volt. So means 36 microcoulomb. Okay. So difference of charge QD, that is 72 minus 36 microcoulomb. That is we get 36 microcoulomb. So here the equivalent capacitance. Equivalent capacitance, very easy to calculate. That is equal to if they are parallel, so that is CT, that is just to be added 6 plus 3 microcoulomb. So that is a 9 microcoulomb. That's the equivalent capacitance. Okay. So final voltage, that is equal to, okay, the charge difference QD by total capacitance, 36 microcoulomb by microfarad. Okay, that's a farad, and here the C is 9 microfarad. They cancel these two, 4. So 4 volt. Okay. So energy calculate. So U1 energy and U2 energy. So energy of before. Okay. So before energy U1, suppose say that. So half CV square. Okay, C1. If when the capacitor are connected in parallel. Okay, that is C2 V square. So half V square means common here 144. So C1 plus C2, so 6 plus 3 9 into 10 to the power minus 6. So here is 72 times 9 into 10 to the minus 6. So 720 into minus 72. So here is that 727. 9 to the 18, 8 carry 1, 9 7 the 63, 1, 64 microjoules. and here the u2, and here you see that u2 when there is exchange, so when the difference, okay, equivalent capacitance difference, okay, u2 equal to half cv square, and the v now is the difference of the potential, okay, so that is half c given the equivalent capacitance, okay, that is a 9 to 10 to the power minus 6 into, so 4 square is 16, 8, 8 9s are 72 microjoule. So difference ud, that is u1 minus u2, so that is 648 minus 72 microjoule. We get 6 and here 7 as a 5, 576 microjoule. That's the answer. Okay, that's a very 10 important numerical on board exam. Okay, so that's very important. If you solve these basic numerical, actually, okay, these are the basic and simple numerical. If you know that the formula, then solving numerical is very easy. Okay, first do the theory, then you solve that numerical. So next class we discuss that some typical numerical. Okay, that's very important JEE and NEET exam also, and there is an advanced numerical we discuss. So today end the class here. Thank you.